All right, Algebra 2 students, what we're going to work on today is section 8.4, graphing square root and cube root functions. This is the final section of chapter 8. Okay, this is the final section. We're going back to graphing. We are going back to graphing techniques here. So, if we start with the square root of the parent graph, of course, parent meaning the original. So this is like the original square root. Of course, we know that the square root is this weird looking thing, which we do have down here in y equals the square root of x. So what I want to do here is I want to start by making an xy table. I've done this before all the way back in 7th grade, and so the big key here is I want x values that I can do, or not can do, can evaluate mentally. So what kind of x values can I evaluate mentally? Well, the only ones that I can think of are perfect squares. So I want perfect squares for my x value. Well, what's a perfect square? The very first perfect square is actually 0. I could take the square root of 0. Okay, if I were to take 0 and plug that thing in right here for my x value, I'm just going to get the square root of 0, which is equal to 0. All right, what's the next one? 1. Okay, I can do 1. The square root of 1 would just be 1. Not hard, okay. Well, what's next? 2? Well, I can't do 2, because the square root of 2, I don't know a number times itself twice that gives me 2 in my head. 3, no, well, next one would be 4. What's the square root of 4? Well, that's 2. Okay. So now that gives me these 3 points, 0, 0, 1, 1, and 4, 2. Now, could I continue? Could I get another one? Sure, I could continue. I could. But I think I'd rather just say, like, okay, that goes on forever. So let's plot these. So I have 0, 0, 1, 1, and then 4, 2. 0, 0, this thing right here, okay, this 0, 0 is known as like a pivot point, okay? This is our starting spot. So here on 0, 0, it's going to start at 0, 0, and then it's going to go through those points and continue. So it's going to go, and it kind of levels off. And that right there, that purple thing, is known as the parent graph of my square root. Okay. Now down here, I got these two spots down here. And what I want to do in these spots is I actually want to list the domain and the range. Okay, the domain and the range. Well, the domain, that's the x's. That's the x values. Okay, x values, well, that's right and left. I always start then with how far it goes to the left. How far will this thing go to the left? Well, it's going to go until I hit 0. So I hit 0. Do I hit 0? Yeah, I hit that point. So I have to include it. And then it goes, how far to the right? Well, it goes forever, so that's infinity. I can't touch infinity, so that is an exclusive bracket, also known as a parenthesis. Next thing I want to do is I want to do the range. Okay, it's the range. Write this thing out. What's the range again? Let's see. That's the y's, or that's how low and how high something goes. Well, how low does this thing go? If we look at it, it goes down until that 0, 0 point. Well, 0, 0 point adds 0, and then how high will it climb? This can sometimes be tricky for us. This arrow indicates that it's going to continue up. It just is going to take it a long time to get there. So it is going to go to infinity. Can't touch that, can't touch 0. And I've done the range and the domain of the parent graph. All right, let's see here. Let's see if we can't do a non-generic example. I have this blue thing over here. This blue thing is already graphed. The blue is the parent graph. That's the parent graph. Just to kind of see how it relates. Okay, just to see how it relates. So let's see here. I still want to make an XY table. I do. I want to make an XY table. But there are some serious issues with this XY table. What I want to do with the X is I want to pick X's that are going to make X plus 2 perfect squares. And then, of course, I want to find out whatever the y. So my goal here is to get perfect squares for X plus 2. So after I evaluate X plus 2, I want to get perfect squares. What are my perfect squares? Well, I want to get 0, 1, and 4. The question is, what do I have to plug in for X? Plug in for X to get each of these values. So let's start with 0. What would I have to plug in for X so that when I put it into X plus 2, I get 0? Well, that would be negative 2. What would I have to plug in to X so that when I plug it into X plus 2, I get 1? Well, that would be a negative 1. What would I have to plug in for X so that when I add 2, I get 4? Well, that would be 2. Okay. This would be a great time, if you did not understand what I just said, to pause the video, go back, and see what I did again. Here I have negative 2 plus 2 would give me 0. Negative 1 plus 2 would give me 1. 2 plus 2 would give me 4. If I evaluate these x values, so maybe for my first example, I won't just do y's. Maybe I'll actually do the whole thing now. So maybe I'll say this is x plus 2 minus 6. And then here at the end, I'll put my y value. So x plus 2 minus 6. Well, my x value, don't forget my x value is this blue thing way over here. So I have a negative 2 plus 2, the square root of that, minus 6. Well, negative 2 plus 2 is 0. Square root of 0 is 0. Minus 6 is negative 6. Okay, well, let's try the next one. This would be a negative 1 plus 2, the square root of that, minus 6. Negative 1 plus 2 is 1. Square root of 1 is 1. Minus 6 is negative 5. Then I have 2 plus 2, square root of that, minus 6. 2 plus 2 is 4. Square root of 4 is 2. Minus 6 is negative 4. This, of course, gives me 3 points. What are my 3 points? Negative 2, negative 6, negative 1, negative 5, 2, negative 4. And then take these and I'm going to plot. So I have negative 2, negative 6. Okay, that would be this point down here. Then I have negative 1, negative 5, and 2, 4. 2, negative 4, sorry. Excuse me. I know the terminal point is always going to be this first. This is the starting. So I know it has to look like this blue graph here somehow. So I start down here and then I just draw it. And there we've created our very first real example. Of course, the question is, what is the domain? The domain here, how far to the left does it go? Well, it goes back to negative 2. It's included there. And then it travels to the right. How far? Well, infinity. The range, how low does it go? It goes down until negative 6, it looks like. It includes that. And then it goes up forever. Even though it looks like it's leveling off, it's not. It goes up forever. And there we have our complete example. Now, that's the full example. What if I asked you to compare this blue graph to this purple graph? How do you move from this point down to this point? I would have to do what? I have to go down 6 and the left, so I'd have to go down 1, 2, 3, 4, 5, 6. So that's down 6, and then I'd have to go 1, 2, 2 to the left. So that's actually exactly what I want to do. Here on the compare, I want to say, oh, you have to go down 6 to the left 2. And we're going to use that here in a little bit. All right, let's look at this next example then here. Here I still want to do my x and y table. Here I'm going to make a very condensed table though. What values do I want this x minus 1 to take? Because it's inside the square root. What numbers can I take the square root of? Well, I can take the square root of 0, 1, and 4. These are always the three values we use. So we're trying to take the square root of 0, 1, and 4. What do I have to plug in then into x right here to get my 0? Well, I need 1, something minus 1 equals 0. Well, that would just be 1. So if I plug that in, that's 1 minus 1 is 0. Square root of 0 is 0, times 3 is 0, plus 2 is 2. I pause there. If you did not catch all that, you need to stop the video, go back. Next value. What do I plug in for x right here so that I can get a 1? Well, I need something minus 1 equals 1. Well, that's 2. I need 2 minus 1. That'd be 1. Square root of 1 is 1. Times 3 is 3. 3 plus 2 is 5. Again, pause the video, go back, listen to what I'm saying. Okay. Try the next one. What do I have to plug in for x to get 4? Well, something minus 1 equals 4. Well, that's got to be 5 minus 1 equals 4. What's the square root of 4? 2 times 3 is 6 plus 2 is 8. I have my 3 points. Well, all right, I've been doing this in purple here, so maybe I'll continue. I'm going to do each one of these 3 points. So I have 1, 2, 2, 5, and 5, 8. You can see this one's like stair-stepping upward. It's going to really gain ground up here. This one looks like it's almost like I took the edge of this, and I just pulled it up. I really stretched it. I stretched it. Okay? Let's see what the domain is. The domain is the x. How far to the left does this thing travel? Well, it travels, it looks like that first point's at 1. So the farthest to the left it goes is 1. I get that point. And how far to the right? Well, it goes forever to the right, so that's infinity. Let's think about the range. The range, in this case, how low does it go? It looks like the lowest it goes is this 2 value. Okay, so that's not that bad. 2 included. How high? Well, it goes forever up, so that's infinity. We've done a lot of range and domains, so that shouldn't be too hard of a thing. Comparing though. Okay, well let's go back. Let's look at the 2. I want to know, how do you go from the blue, this thing right here, to the purple? Well, I have to do what? I have to go right 1. I have to go up 1, 2. So I have to go up 2. And then you see how much more vertical this is. It's way taller, right? It's almost like it's been stretched. In what direction? Well, it's been stretched vertically. This is a vertical stretch. Okay, so let's list out what we just did. Oh, well, it went right 1, up 2, and then there was a vertical stretch. Let's look at the original. Let's look up here at the original. Would anything have given that away? Well, let's see here. This 1 right here, hey, that means right 1. Oh, it went up 2. Maybe this plus 2 means up 2. I wonder what this 3 did. Well, the 3 is a pretty big number. Maybe it's a vertical stretch. Let's just keep that in our minds as we progress through. now I move on to cube roots though. Oh, I throw your curveball. Now I'm going to do cube roots. Well, let's think about this. Let's see if we can't think our way through this. I want a cube root parent graph. What did I say before? Well, the parent graph, okay, this is like the original. Okay. All the other ones are going to come after this one. So it's worth our time then to make our XY table here. Big key here now. We want X values that are perfect cubes. We want perfect cubes. What are some perfect cubes? Well, just so happens 0 is perfect. Okay, 0. What else? One's a perfect cube. What's the next perfect cube? Well, I know that 2 times 2 times 2 is 8, so I think 8 is the next perfect cube. Question is, can I do negatives? Yeah, I think I can do a -1. Cube root of -1, that's just -1. What's the cube root of -8? Well, that's -2. Okay, let's see. Let's see what this is all about. So I'm taking this -8 and I'm plugging it in right here. So I'm thinking, what's the cube root of -8? Something times itself 3 times gives me -8. That is -2. So -1, what's the cube root of -1? Well, that's just -1. What's the cube root of 0? 0. What's the cube root of 1? 1. What's the cube root of 8? Well, this is positive. That gives me how many points? Well, 5. I got -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Well, let's graph this and see what it looks like. -8, -2. Okay, down here. -1, -1, 0, 0, 1, 1, 2, 8. Or, I'm sorry, 8, 2. Look at this thing. Let's try and draw it. It looks like it looks almost like an S. This is known as an S curve. And all cube roots will look like an S curve. Pay attention here to the arrows. This arrow right over here, I'm going to circle in red here, don't get confused with the color. This guy right here is actually pointing to the left and down. Left and down. So down towards the corner. This one right here is pointed to the right and up. I say that because down here on these lines again, I want to do the domain and the range. The domain of an S curve is always going to be -infinity to infinity because it goes forever to the left and forever to the right. Well, let's think about the range then. The range now. If I said this goes down forever, well, that's -infinity. How high? Oh, I said it went up, so that's positive. Again, non-inclusive brackets, also known as parentheses there. And that is the S curve, also known as cube roots. Let's try an example then. Let's try an example. Here I want to create an X, Y table. I need this thing right here to be perfect cubes. I need perfect cubes. What are perfect cubes? Well, we just talked about -8, -1, 0, 1, and 8. That means when I create my X, Y table, I need to figure out what X value I put right here so that I get out these numbers. So to get a -8, what would I have to put there? Well, I would need a -4. -4 minus 4 is -8. What's the cube root of -8? -2. -2 minus 2 would be -4. First one done. Next, what do I have to do? What do I have to put right here for X to get -4? Well, I'm sorry, what do I have to put in here for X when I do X minus 4 to get -1? Well, I need, what would I need there? I need a negative, no, I don't want a negative. I need a -1, so this is a 3. Oh, a 3 minus 4 would be negative 1. What's the cube root of negative 1? Negative 1. Okay, negative 1 minus 2 is negative 3. Notice that this goes negative 4, negative 3. Maybe our logic tells us next, maybe I'm going to get, oh, I don't know, a negative 2 here. Well, let's see. What do you have to plug in for x to get 0? Well, I'd have to put in a 4. 4 minus 4 is 0. Cube root of 0 is 0. Minus 2 is, oh, look at that, negative 2. Let's keep with the logic. Oh, well, maybe this one will be negative 1. What do I have to plug in for x to subtract 4 to give me 1? Well, that's 5. 5 minus 4 is 1. Cube root of 1 is 1. Minus 2 is negative 1. Finally, I go, what do I need to put in, again, for x here, so that I get out this 8? Well, that's going to be a 12. And if I plug in 12, that's 8. Cube root of 8 is 2. 2 minus 2 is 0. And I have all of these points. Last time I used purple, so I think I'll keep with that. Let's do a purple right here. So this is negative 4, negative 4. This point. Okay, then I go 3, positive, down 3. Here. Then I have 4, negative 2, 5, negative 1, and 12. Oh, I need to extend my graph a little bit, no big deal. Put my 12 right there. And let's look. Let's try to draw this. So it's going to curl up. It should look like an S because it's cubed. And look at that. We have our first cubed function. Let's see if we can't do the domain. Oh, that's right. The domain. I already said it's going to be negative infinity to infinity every time. Oh, the range. Same thing. Range. I said it was going to be negative infinity to infinity every time. That's easy. What else does it ask me to do? Oh, compare. Comparing. All right. Well, let's look at it. How do you go from like the center? Like this is the center of the old one, remember? How do I go from that center to this center over here? Well, I go what? 1, 2. That's down 2. Then I go 1, 2, 3, 4. Okay, so that's right 4. Now, do they look like the same S? Yeah, they don't really look like they've changed all that much. Of course, the easiest way to tell is from the middle point, how do you go to the next point? Well, that's just up 1 over 1. Perfect. Down 1, down 1 over 1. Perfect. That's the same type of thing that we did on the original, if you think back to that. Okay. So down here on the compare, I went down. Oh, I've already forgotten. I just was looking at it. I went down what? 2. And then I went right. Could I have guessed that looking at my little graph here? Oh, look, right here, this 4, and negative 4, just like the one with the perfect squares, that one meant right 4. Negative 2, though, that means we went down. Again, just kind of keep that in your head as we go down through this. So, let's see this one here. Okay, well, I know this guy right here I want to be negative 8, negative 1, 0, 1, and 8. So when I create my xy table, I'm thinking about x values that I'm plugging in right here that are going to give me these. What am I going to need to plug in for x to get a negative 8? Well, I need a negative 9. Negative 9 plus 1 would be negative 8. Cube root of negative 8 is negative 2. Okay, what's negative 2 times 1/2? What's half of negative 2? Well, that's negative 1. Negative 1 plus 3 would be 2. All right, that's not terrible. What about the next one? Okay, how am I going to get negative 1 out of here? What do I have to plug in for x to get this negative 1? Well, I'm going to need a negative 2. Negative 2 plus 1 is negative 1. Cube root of negative 1 is... Alright, guys. I'm not going to lie to you. I actually made a little mistake here. I did not even see this negative sign when I was staring at my board here. So, I'm going to have to stop right now, and I'm going to have to restart this problem. I think what I'm going to do, because I'm running out of time right now, is I'm going to stop and I'm going to make a new video. Okay? I'm going to erase this real quick. I'm going to erase this real quick in this video right here. I will say right now, okay, pick up with 8.4 video 2.